Here are your notes for section 10.3, solving radical equations. So what is a radical equation? A radical equation is an equation that contains a radical expression with a variable in the radicand. So we have to have an equation, which means we have to have an equal sign. And then you can have whatever you want to over here. We can say 5. The radical expression has to have a variable in the radical, or as the radicand. So the radicand is whatever's underneath the radical symbol. So we'd have to have a variable here. So we can say that, and we'll say, I don't know, minus 48. All right, so that would be a radical equation. We have a bunch of them that we have to learn how to solve on these notes. So the first thing you're going to do when you're going to try to solve a radical equation is to isolate the radical, get it by itself. So just think of this, if this was x plus 5 equals 13, to get x alone, you'd subtract 5. You're going to do the same thing here. Subtract 5 from both sides, and you have the square root of x is equal to 8. Now, we don't have just x equaling 8, we have the square root of x equal to 8. So some of you might say, hey, I know what that is. That would be 64. Well, that is correct because the square root of 64 is 8. But the way that you solve this is you would take the inverse of a square root. And the inverse, meaning the opposite of a square root, would be something that we would square, all right? So the square root and the square cancel, and now you're left with x is equal to 64. And when you're going this way, it's only positive 64. We couldn't have a negative 64 as our answer because you can't have a negative radicand. All right, so your answer is 64. And if you wanted to check it, square root of x, which is 64, plus 5. Well, this is 8. 8 plus 5 gives you 13. And that's what we had up there. So we have the right answer. X is equal to 64. Okay, for this one, there's an extra step. So if I rewrite the equation, let's get the square root, the radical, alone. So let's subtract 3. And the biggest mistake students would do would be to do this to me. And I would say, nope, you forgot there's a negative in front. So that has to come down. We haven't gotten rid of that. But let's get rid of that now. Hopefully you know that if the negative's in front, it's like negative 1 times the square root of x. So to get rid of it, we would divide by negative 1. So then we have the square root of x is equal to positive 3, which is a good thing because you can't have the square root of anything equaling a negative number. It doesn't work. So now the inverse operation here would be to square both sides. The square root and the squares cancel, so we end up getting x is equal to 9. And if you check that, here's your check. We'll do it up here. 3 minus the square root of 9. Does that equal 0? Well, 3 minus, what's the square root of 9? That's just 3. Yep, that equals 0. We did the right work. Okay, let's make it a little bit harder. And we have 4 times the square root of x plus 2, outside plus 3 is equal to 19. So think of this as 4x plus 3 equals 19. When you go to solve for x, the first thing you're going to do is you're going to subtract 3. And then you'll have 4x is equal to 16. And then to get x alone, you'll divide by 4 and you get x is equal to 4. Now, this is not the answer we're going to come up with because we don't have x. We have the square root of x plus 2. But I just wanted to show you that's the mentality you're going to use in order to solve this problem. So let's first subtract 3 to get the square root alone. So that goes away. We have 4 times the square root of x plus 2 is equal to 16. Now to get the square root alone, it's being multiplied to 4. So we divide by 4, and we have the square root of x plus 2 is equal to 4. At this point, we have isolated the radical. The only thing on the left side is a radical with the radicand inside. All right, so now we can square it because that'll get rid of the square root and the square cancel one another. So this comes out of the radical symbol. It's no longer a radicand, it's just x plus 2. That's going to equal 4 squared is 16. We'll subtract 2. And so we get an answer of x is equal to 14. All right, so make sure you understand that's just showing you it's not that complicated. Just follow the opposite order of your order of operation, okay? Because remember, when you're solving, and actually we should do it like this. All right, please excuse my dear Aunt Sally, parentheses, exponents, multiplication to division from left to right, addition, subtraction from left to right. When you're solving an equation and a variable, you do the opposite. So that's why we subtracted the 3 because it was being added, and then we divided by 4 because it was being multiplied by 4, and that's why we went that way. All right, if you want to check your answer, 4 times the square root of 14 plus 2, and then we'll add 3 on the outside. This is 4 times the square root of 16 plus 3. Well, this is 4 times square root of 16 is 4 plus 3. 4 times 4 is 16 plus 3, we get 19. And that is what they had up there. So we have the right answer of x is equal to 14. Okay, if this situation occurs, you have a square root on both sides. We have 2x minus 1 is equal to the square root of x plus 4. Well, if you're looking to get rid of your square roots, you would square. But if you square the left side, you have to square the right side, which works out fantastically because it gets rid of these square roots, and you no longer have radicans. You just have 2x minus 1 is equal to x plus 4. And you know how to solve this. This is just variables on both sides of an equation. I'm going to subtract x. I usually move my variables first before I move my constants. I'm going to add 1. And so then I have x is equal to 5. Now, before you move on, you do have to check your work. All right, so let's check the square root of 2 times 5 minus 1. Does that equal the square root of 5 plus 4? So 2 times 5 is 10 minus 1. That would give you 9. Does that equal 5 plus 4? That's 9. Square root of 9 does equal square root of 9. So we have the right answer. Okay. You're going to want to have your calculator in front of you right now. Okay, so we have solving a radical equation involving a cube root. So we have the cube root of 5x minus 2 is equal to 12. I want to get rid of the cube root. Well, what do you think would do that? Hopefully, if you said I'm going to cube it, you are correct. So if you do cube root of something cubed, it goes away. So our radicand is no longer a radicand. It's just 5x minus 2. And then in your calculator, 12 to the third power. So if you don't know how to put 12 to the third power into your calculator, you would type in 12, and then you would find this symbol. It's a caret. It is above the x squared button, and you would put in the caret, and then you'd press 3, and that would give you 12 to the third power, which would equal 1,728. Okay, so now we have 5x minus 2 is equal to 1,728. We're going to add 2. So we get 5x is equal to 1,730. Divide by 5. And your final answer would be x is equal to 346. Let's check that, and let's talk about how to put a cube root into your calculator. So if we had the cube root of 5 times 346 minus 2, let's see if that equals 2. So first, 346 times 5 ends up giving you 1730, and then when you subtract 2, you get 1728. So, and let's make sure I put the cube symbol there. How do you put the cube root into a calculator? So I think that it's important that you learn how to do this. On your calculator, you know how to put a square root in. You do second x squared. To do a cube root, what you're going to do, if you have a TI-30, is you're going to put in the number 3. And that number 3 is actually the cube symbol. You're telling it that you're going to take the cube root. If it was the 4th root, you would put a 4 in there. The 5th root, you put a 5 in there. We have the cube root. Then in your calculator, you're going to press second and the caret symbol, because above the caret symbol, you'll see this. All right. And essentially, you told it that x was 3. All right. So the cube root of, you would then type 1728 and press the equal sign. So go ahead and do that in your calculator. Do 3 second, the caret symbol, and then in your calculator, it should say 3 and have like the x with the radical symbol. 1728, press the equal sign, and in fact, we do get 12, which is what we wanted. So we have the right answer of 346 for x. All right. We have to check for what's called extraneous solutions. So in this, I know you guys might not like checking your work, but if you've noticed throughout these notes, I've been checking my answer every time, and you have to do that because when you're dealing with radicals, sometimes what's called an extraneous solution occurs where you get this answer, but when you check it, it doesn't work. So really, there's no answer. So let's try it. So for this one, we have x is equal to the square root of x plus 6. Well, I want to get rid of the square root, so we're going to square it. But whatever I do to one side, I have to do to the other. So that goes away, and we have x squared is equal to x plus 6. You know how to solve this. You just took a test on solving quadratic equations. We're going to subtract x and subtract 6 from both sides. And I have x squared minus x minus 6 is equal to 0. For me, I'm going to use factoring. You can use a different method if you'd prefer. But we have what times what gives you negative 6. I'm going to do 3 and 2, and I need to add them up to negative 1. So this will be negative. That'll be positive. Okay, so x minus 3 is equal to 0. When I add 3, I get x is equal to 3. That's one answer. X plus 2 is equal to 0. And when I subtract 2, I get x is equal to negative 2. Now, before I circle these, I need to check my work. So let's go back and let's check. Let's check if x is equal to 3. So we'd have 3 is equal to the square root of 3 plus 6. Does 3 equal the square root of 9? And in fact, it does. Square root of 9 is 3. So we can circle that as an answer. Let's check if x is equal to negative 2. So we have negative 2 is equal to the square root of negative 2 plus 6. Negative 2 is equal to negative 2 plus 6 is 4. So the square root of 4, does that equal negative 2? And the answer is no. The square root of 4 is positive 2. So this is known as an extraneous solution. When we put it in and solve for it, we get negative 2, but when you check it, it doesn't work. So we have to cancel that one out. It would be incorrect if you circled both of those answers and said that they work. Okay? All right, let's do 13 plus root 5n is equal to 3. So let's get the radical alone. So in order to get this alone, we first have to get rid of 13. So let's subtract 13 from both sides. We have the square root of 5n is equal to negative 10. To get rid of the square root, let's square it. And you'll understand why in a second, but I'm going to do 5n, square root of 5n equals negative 10 again. And let's square both sides. And this cancels, so we have 5n is equal to negative 10 times negative 10 is 100. When we divide by 5, n is going to equal 20. Okay, so check your solution, make sure it works. When we check, we have 13 plus the square root of 5 times 20 equals 3. So 13 plus 5 times 20 is 100. 13 plus square root of 100 is 10. Does 23 equal 3? And the answer is no. So this answer doesn't work out, there is no solution for this problem. Okay, and the reason why I rewrote it essentially here is because when I look at this, and some of you may have looked at this and said, hold up, you have the square root of something, whatever is going to be inside, is it ever going to equal a negative number? And the answer is no. So in my head, right at this step, I'm like, there is no solution for this problem. All right, but if that's not super obvious, that's totally okay. Solve it, get your variable isolated, solve for it, and then check your work to see if there is an extraneous solution. Okay, what I would like you to do is on this page, I would like you to pause the video and do numbers, let's do 1 through 3, and then unpause the video and check your answers. Okay, so here are the answers, and I hope that you paused the video and did them on your own. But your answers should be 16, 121, and 9. Now, realize, yes, this is equal to a negative number, and that's okay because when you end up adding 15, you get a positive 9 dividing by 3 gives you a positive 3. So the actual radical is a positive. When the radical is isolated right here, it's a positive number. All right, so all 3 of those work nicely. Okay, let's, just for time purposes, I want you to pause the video. Let's do this one, number 6, and let's do number 9. So go ahead and pause the video again, make sure you're doing the work, and check your answers. Okay, so here are the answers for 6 and 9. For 6, hopefully you got x is equal to 14, and for 9, hopefully you got b is equal to 4. Okay, let's look at number 12 together. If you ran into something like this, just if you see oh, there's 2 radicals on one side, well, let's get one of the radicals to the other side. And it cancels out on this side, and we have the square root of 3w plus 1 is equal to the square root of 6w. And then it's exactly like number 9, where you would square both sides. And you would have 3w plus 1 is equal to 6w. And then from here, I would subtract the 3w since w is on both sides. And I'd have 1 is equal to 3w, divide by 3 to isolate w, and you end up with 1/3. Okay. When you check it, you might be a little scared because you got a fraction, but that's no big deal. Check out what happens. We have 3 times 1/3 plus 1 minus the square root of 6 times 1/3. So here, these cancel, and you have the square root of 1 plus 1, which is the square root of 2. And over here, 6 times 1/3, well, you can simplify. This goes to 1, this goes to 2. So 2 times 1 is 2. So the square root of 2 minus the square root of 2, yep, that would give you 0. Okay, remember we have to look out for those extraneous solutions. So let's just do a couple more on your notes. Let's do number 15, and let's do number, how about we look for number 17. So go ahead and pause the video, and one is a cube root, the other one we are dealing with extraneous solutions. Always look for those. Okay, so here are your answers for number 15. Hopefully you got m is equal to 2. And number 17, it's no solution, because when you get b is equal to -1 and you check it, you have the square root of 1 is equal to -1, and that is not true. Square root of 1 is +1, so 1 does not equal -1, therefore there's no solutions. Now, remember the example we did before in our notes, sometimes there's one solution that works and one that doesn't, so it's possible that that would occur. I do want to do number 13 together as our final problem. We have 5 is equal to the cube root of x. And the reason why I want to do this is just so you understand how to do this in your calculator. So you would cube both sides to get rid of that cube root. So in your calculator, 5 caret 3. So when you do 5 to the third power, you end up getting 125. That is equal to x. And then that would be your answer. To check it, if you wanted to check and find the cube root of 125 in your calculator, remember you put that 3 in to signify that you have a cube root. Then you would do second, the caret symbol, and then type in the radicand, 125 equals, and you end up getting 5, which is what we wanted. Okay, for the remainder of the period, you will be working on big ideas for 10-3. 10-1 big ideas should already be completed. 10-3 is not due until Sunday evening. This concludes your notes for section 10-3.